Hello, welcome to CS 112, lesson 12.3, loops. This is made with the University of Idaho CS 112 computational thinking class. If you have not already, we will be starting with a warm-up, which is now on the screen in front of you. Take some time, fill this out. Once you've done that, see what happens. Go ahead and hit that play button. And provide a response to your teacher in the way that they see fit. Moving on, if you need more time, you can definitely stop this video, pause it. So looking at the warm-up code, we're going to notice a couple of variables, center X and center Y. Hopefully you noticed whenever we first started off that those are actually declared as global variables. Global, remember, are available throughout the entire program for everything to kind of reference. In comparison, there are local variables, which are used inside of a specific procedure, as kind of mentioned here. So kind of something important to realize is that setup and draw are two different procedures. Setup happens once, it sets it up, whereas draw is continuously happening. Some people kind of struggle with the idea, and kind of the big thing is imagine that you draw a piece of paper and then you draw another piece of paper and you draw it again. It's kind of like one of those animations that you might see. However, this isn't always good, especially whenever we start talking about variables incrementing over time. We only want something to happen so many times, and we can actually set that up so that it doesn't happen continuously like it does with the draw function. So in this lesson, we're going to talk about variables and how we increment them. We're going to talk about two different types of loop statements. And we're going to make an assignment from this, which you saw on the first slide. That's kind of what our end goal is. That makes circles of different sizes that are also different colors. The first thing that we're going to talk about is how we increment variables. The way that we do this is we initially can set the value of a variable, and we can have it just stay the same the entire time. There's a kind of shorthand version to increase a variable, and specifically to increase a variable by 1, and it's this right here, this j++, and really this could be any variable. I could name this variable and it would do the same thing as long as I did variable plus plus. So this plus plus, kind of the idea is we increase it by 1. Additionally, or kind of in addition to that, we can increase the variable by a certain amount each time, such as, let's say, 13, with using this j plus equals, and really it's the plus equals that we're looking at here. This plus equals says plus and equal to what we were before. So we equal j, so whatever j was before, plus 13. Go ahead and try these, and whenever you put this into your code and you run it, in the bottom of the screen you should see a couple things pop up. You should see specifically these 3 things. So I'm going to go ahead and run over and do that now just so that you can see, hey, did I do this correctly? So I'm going to clear out this warm-up that we did. The way that we do it is we do int I equals 0. So remember int being an integer. We talked about that last time, I believe. Print ln of I. What this does, this is going to return, and it's going to put what the value of I is down in this console down here. We do an I++, and what this does is this is going to increase by 1. And we're going to print this again, print ln of I. We're going to try another one. We're going to do I plus equals 10. And let's print this as well so that we can make sure that it's actually running correctly. Oops, not in. If I click the play button, little thing's going to pop up in the center. We're not actually looking for that. We're looking down here where it's 0, 1, 11. You'll have seen it start off with 1, 11. It's just because I have it big on my screen. So 0, 1, and 11. You should be able to scroll up if you need to. Okay. All right, go ahead and close that for you. So that's how we increment code. The next thing we're going to talk about is how we loop and repeat. There's two different ways of looping or repeating in processing. The two different ways are a for and a while. For it sets the variable in the loop and it tests for the end. The while sets the counter variable before the loop and tests for the end. When they're used, the loops are still run multiple times, and they kind of reset. And it's kind of hard to get our minds about what these things mean just looking at the words. So we're going to look at a couple of examples. So for we initialize the variable, we test the variable for an end, then we update the variable. After that, we have our command block here where it tells us the different statements that we're going to run. Let's try this example right here. So I'm going to clear this out so I don't have to deal with it anymore. So for, I like to have that kind of right next to it, int I equals 20, I is less than 200, I plus equals 10. Give it a command block here. Let's make a line, I 30, I 60, and end that command block right there. So what we're doing here is we are initializing the variable I. We're saying, hey, there's going to be a thing called I in this, and it only exists, it's pretty much a local. It only exists inside specifically this for loop. So I could have multiple fors using I. I don't really recommend that, but it's something that you can definitely do. Unless you decide to use I for all of your for type loops, then it's actually pretty handy. I just don't like kind of jumping back and forth, being like, oh, I'm going to call this one I, this one J. And what's important is you can actually put loops inside of loops, which is really handy, and you actually wind up using that quite a bit. So in this case, I initialized I, made it 20, and I test and make sure is I less than 20. If it is, I know that I'm done. Otherwise, I'm going to continue this. So in this case, I say, okay, I plus equals, so I plus equals 10, so this means we're going to add 10 to whatever I was before. That's the entire kind of like test statement, if you will. Like, okay, we're starting at 20, we're doing this, we're doing this. What happens for each time that we run this, notice I use the word for each time we run this, we use this line I 30, I 60. And what actually happens is we increase our I each time we run through this for loop. So if I run this, I get a set of lines that go all the way across. Go ahead and close that. And that's where our result is. Now, another one that we have is a while loop. Personally, I'm a little more of a fan of the for loop. So what we have here is we have to initialize the variable before we actually say the while loop. Then we give it what to test. We give the statements that we want to do, as well as we need to make sure that we're incrementing whenever we have this while going. So let's try making this similar to this for loop that we made earlier. So I'm going to slash star this. Remember, that's how we can kind of easily mass delete things. And this way I can make it so that we can go back and forth, so we can check it out and kind of see how they're different. So we need to, outside of the while loop, we need to initialize and set the integer I and set it equal to 20. Then we do while, and we give it what to test. So as long as I is less than 200, we want to do this. Maybe that's the size of our screen, or we don't want it to go any farther than that. Now we need to give it some commands. So I'm going to say, okay, I want my line to draw from I to 30 and I to 60, and give us a semicolon. Then after this, do I plus equals 10. So if I run this, that looks identical to the for loop. And in all reality, actually, this is identical to the for loop. There are times where a while is more helpful than a for, and a for is more helpful for the why. Like I said, I kind of prefer the for because I like to put everything all in kind of one thing so that I'm not missing it somehow miraculously down here. I actually forget, oh, I don't increase it at all ever. Um, However, there are times where maybe you want to run a whole bunch of these while loops in a row and then change your I. Okay. And this is what we'll do. We'll actually delete this. And if we run both of these, they're actually drawing right on top of each other. All right, let's try another bit of code. Delete that. All right, go ahead and try this one. So let's set up a size. Let's go size. And let's take it something different from what we normally do. Let's do 330, 120. Background. Sets the background to be a specific color. Let's say 0, which is the absent all light, so it should be black. No stroke, which just simply says we don't want it to have any kind of outlines that we're drawing. Now, I kind of told you before that we can actually embed fors within fors or whiles within whiles. We can embed those, and actually becomes pretty handy, and we're actually going to do that right now. So for initialize y to be 0, just give us a space right there, semicolon, y is less than or equal to the height. So as long as y is less than or equal to the height, we want y to increase its value by 30. And we give it a command block. And what we're going to do here, we're actually going to add in another thing for the x so that we can kind of fill up the whole screen with this kind of cool little thing we're about to draw. So for an integer x, which starts at 0, I want x, as long as x is less than or equal to the width. If I could spell, that'd be nice. And you might x to increase its value by 30. I want to fill with a color, and we're going to say 255, comma 140. Now, if you forget, what this is actually doing is this fill, this is saying white, but not totally transparent, and so this is actually going to be kind of a gray. We're going to draw an ellipse, which you remember is like a circle, but we can make it kind of ovalish if we want to. And we're going to use x, and we're going to use y, because that's the x location and the y location. And we're going to make it a circle, so we're going to go 30, 30. Now if I run this, we have this kind of really cool pattern kind of showing up, and it almost looks like we drew diamonds, but actually we drew these gray circles. If you look right there, you're like, oh yeah, it's actually a circle. So one thing to kind of note is we actually run, so we're running this, so if you want to kind of think program of like how the computer's running, it runs size of background, and it starts doing this for loop. And in actuality, the first time through this loop, it runs this X loop, and it keeps running this until the X's, this for loop right here finishes, and it says, okay, we're at the end of this. And then we test this again. We run through this for loop, and so we keep running this over and over and over and over until we satisfy this. Why do you just kind of think about why do we think we'd run this fill each time that we run through it? Let's try moving it. Let's see what happens if I move this. Okay, looks the same. And still looks the same. However, the reason that we do this is something that I kind of alluded to is I don't trust people. Um, what really it should be is we're running this fill each time just to make sure that we're drawing the correct circle. Maybe for some random reason you're like, oh, I'm going to make this a fill of 0. Let's see what happens. And this really shouldn't do anything because again, we've put this fill in beforehand just to make sure that we're drawing our ellipses correctly. So in kind of making it foolproof, I made it foolproof. Okay. And we kind of ran through this of how I could have the fill in different locations. Um, just because I'm not huge and I kind of don't trust it, I like to put my fill in here. However, it's not necessary if you're paying attention. And in talking about trying to make more efficient code, changing the color every time actually takes up a lot of computer use. Because we're running the same thing over and over again, but it's still having to go in, it changes it, and then it continues the program. So really, because we are kind of drawing this already, we don't have to, but we can. One other thing that we want to kind of talk about is we can use something called no loop. And this is helpful in testing for errors, making sure maybe it's our loop that's doing the error to us. So we can put in this command called no loop. And it can be put in to tell it to only happen one time and tell the draw to happen one time. Um, and so that's pretty handy, especially if you come to something of like a, let's say, an end game type thing where you beat the level. This is where you would put a no loops to say, okay, we're done. We're not going to kind of do anything else. So that kind of actually concludes this lecture. And what you're going to do is you're going to make something. So this is going to be assignment 12.3. As I said at the very beginning of the video, it is present on the very beginning of the video. You can kind of see it underneath the 12.3. What you're going to be doing is you're going to make a processing program that has a size of 300 and 300. Declare this in the setup. It's a first time. It's a one-time thing that we do. You can use either a while or a for loop to draw concentric circles, which are circles that have the same center location that should increase in size and should be centered at the center of the canvas. Draw each color with a random color and have no fill color. Draw the largest circle so that it completely fits on the canvas, meaning it doesn't go off to the edges. It should only get to the complete edge. It shouldn't go off of it. And draw the circles spaced far enough so that the background can be seen between each one. You should include comments for each section of your code and the general program. You can use no loop if you want it to stay static, or you can make it so that it's continually flashing colors if you want. In the end, submit this file as assignment 12.3. If you forget how to zip a file, check out the how to zip a file video. This is a display of what it should approximately look at like. These circles actually should go all the way out to the sides. And as always, happy coding!